Right. See, we learned that quality of service is to identify traffics and provide different service. We cannot give same service, similar service for all type of traffic. Can you give same type of service to all the traffic in the road? No. Cycle have got different type of service. People going in walk, they have different walking platform, and for those who are going in a car, they have a different lane to follow. Heavy vehicles have got different lane in some roads. Only then the traffic in the road can be managed. So the lanes are nothing but queues. We have different lanes like pedestrian, the walking platform. That's one lane for walking people alone. You cannot go in bike there. Sometime in Bangalore, when there is heavy traffic, people take that walking platform and get fined. That's not the right queue for for a motorbike to go. Only for walking that queue is meant. But this fair queue is not like that. Fair queue is not having any lanes. There is no fixed lane. You don't have a fixed lane for walking people, separate for bike, two-wheeler, separate four-wheeler, separate six-wheeler, separate. You don't have such things. Fair queue is just giving fairness. Automatically gives equal bandwidth to each traffic flow. How the flow is identified? By the source, or by the destination, or the combination of both, or by the source port, or by the destination port, or by the protocol, or combination of two or three of this. That is how you identify a flow. Say, for example, if traffic is coming from source A and source B, you give equal amount of bandwidth for both. Not A alone consuming all the bandwidth and making B to suffer. This is what called as fair queue. Fair queue. When you go to take a ticket, you have two lines, one for ladies and one for gents. That's a very good approach actually. Two queues. But nowadays people, they don't follow that. They say, hey, we are equal, and then they really spoil that ecosystem. Saying we are equal, we will have only one queue, and they do all nasty things. But early days that was not the case. In railway station nowadays you have only one queue. You go like this, take ticket and go. Whether you are a woman or a man or a lady or a girl or a boy or whatever. That's not really good. So we used to have different queues, and one ticket given to lady, another ticket given to men, again second ticket given to lady, another. No, that's a round robin. Very nice thing it was there in early days. See, that's fair queue. Fair queue. Not giving tickets only to men and making ladies to wait, or only giving ticket to ladies and making all the men to wait. There is a fairness. There is a fairness. There is some justification done. Depending on the source. If traffic is coming from two different sources, then they are considered as two different flows, and they need to be given equal amount of bandwidth. If I have 5 different sources coming at the same time, then divide that 100 meg into 20 meg each. All 5 will have equal share of bandwidth. This is what called as fair queue. But again, it is old method. This is something better than nothing. When you don't have QoS, whichever comes in the hardware queue first will go out first. That is called first in, first out. So if source A is coming with a big traffic, the entire bandwidth is given to source A, and source B have to wait and then get tail dropped. But when you enable fair queue, A is also using, B is also using, C is also using, equal bandwidth is given. That is fair queue. Fair queue is something better than nothing. When you don't have queuing, it is FIFO. It is very bad. Fair queue is better. But why it is not a best one? Why it's not best? You see, I always remember airport because that is the place where some decency, some quality of services seen. Not in any other places. Some, to an extent, you can see. There will be a first class queue. There will be premium class queue. And there will be also an economic class queue. Economic, there will be more people, so big queue. What I am trying to say is, economic class people are not totally asked to wait. As the first class and business class and premium class are going, economic class is also going. So there is 3 different people checking the boarding pass and letting inside the gate. This is not seen in fair queue. Okay, anyway, this is also kind of fair queue. All 3 are able to board the plane or get through the gate. This is a fair queue. If no fair queue, then what is done in India? You can see this. What I'm going to say now. Though I say airport, India is exceptional in everything. Everything we are not an ordinary people, man. We are great, For us, we no need queue. If we say the customer stop, they will stop. They will not question. So we will stop these guys completely. There is no fair, that's why it is named as fair queue. This is not fair. Economic class people are totally stopped. No. Let the first class go and the business class go. Then we will open the gate according to the zone wise. We'll call zone C and then zone B and then zone A. Zone A should wait for 30 minutes standing in the queue. That's the super fair queue Indian will follow. But that's not really fair. That can't be called as fair queue. Here you see what it says, equal. Yeah. So you can interpret like this: source IP address, first class, another source from business class, another source from economic. All are able to go through the gate simultaneously. So there is some fairness. But here, one packet of first class, one packet of business class, one packet of economic class, which is not at all complete fairness. You see here you have 300 economic class. You just got 15 first class and then maybe 25 business class. That's the maximum seat you have. For that you are keeping one queue. And you are saying one person from economic class, one person from business class. How can it be fair? Is 300 equal to 15 or 25? No. This problem is because you did not classify. You see, these guys really need more bandwidth than the other two. For that, first of all, we need to classify and say, hey, economic class are too many men. So 10 economic people. When 10 economic people get in, one first class and one boarding class should go. Meaning, give more importance to economic class also. Yeah, it is good that you give importance to first class and business class. They have paid 3 times or 4 times more the ticket amount of the economic class. That is true, but they are going to get into different entrance of the flight. In Emirates, you will have different entrance actually. In the front itself, you will have 2 doors. Economic class 1 door, business and first class another door. Then why can't you allow more economic class fast boarding compared to first class and first class and business class boarding? Business class and first class in total only you have only 40 people. This is 300. So make fast boarding for economic class. How do you do that? Make that lane faster. Put more people to check the boarding pass so that economic class can get loaded faster, because 300 need to get boarded. That type of classification first need to be done. So normal fare queue, no classification. But weighted fare queue, you classify them and you put weightage. See, this is economic class. You need to give more important because more people. Okay, you give weightage according to the this is weighted fare queue. This is not class based weighted fare queue. I am again taking my word back. This is simply a weighted fare queue. In this also there is no classes, but different weightage is given. You remember we did marking. Depending on the marking that you do, bandwidth allocation is dynamically done. Marking with AF43 and marking with AF41, which is more weightage. Which has got more weightage? Answer, someone. I'm talking about DSCP.
41.
Correct. See, that is what called as weighted fare queue. You mark the traffic and then you put them in the queue. Now, automatically, the classification is done. You don't need to classify. According to the weight, they get more bandwidth. Compared to 43, 41 will get more bandwidth. That is called weighted fare queue. I hope you understand the difference between fare queue and weighted fare queue. In fare queue, there is no weights and all. No marking, nothing. You just say, I want to enable fare queue. So it will simply see the source IP errors and differentiate the flow, put them in different queue, give them equal bandwidth. Whereas weighted fare queue will look for what you have marked. According to the weight, according to the marking, according to this weight, automatic bandwidth allocation is done. That is called weighted fare queue. Now, as we already spoken, AF11 will have more weightage than AF43. Likewise, EF will have more than AF, And AF will have more weightage than B. B is nothing but best effort. Best effort. For FTP, you see, we give only best effort. Best effort means what? This is the maximum I can do for you. I'm doing my best. But see, not given high priority. Not given high priority. You need to pay fees, school fees for your children. You need to pay some online course fee, and you also need to pay for toys. So where I give like this online classes. EF, high weightage. Why? If you don't pay online classes money, they block some service for children. See how bad it is. Children cannot fully utilize the sessions. They cannot do homework, something like that. You have to pay. That's how my children are. So I give more important to online classes of my children than the school fee. School fee, even if you go and ask excuse for 1 month, it is okay. They will manage. But for the toys, I'll do my best. Wait for God to bless me more. Wait for that day. Trip is not so important. Wait for that day. I tell my children, you need to wait for God to give more money. You cannot simply keep planning for trips, planning for shopping. No, 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 no. You ask God, not me. Because I have commitments. I have prioritization. So, this FTP is like toys, trips, not so important. This is web traffic. This is voice traffic. Among these three, voice are tiny traffic. Not only that, time sensitive traffic. So they need more attention. They should be sent as fast as possible. Delay is not acceptable in voice and video and streaming traffics. Web is the second priority. FTP is the lowest priority, file transfer. If not now, later also you can send the file. File is TCP based, It is okay. It's a fatty traffic, too big. So you can send it slowly. Even when you are sleeping, you upload and sleep. That's not the case with voice and web surfing. So we give weightage according to the weightage. The QoS is done. See, simple one command only. That's it. Fair Q is done. All right, one command to enable fair Q. Just go to the interface and say fair Q. What is fair Q? We saw in the top. No weight. No weightage. Equally shared. Automatic queues created according to the number of flow. 5 flows, 5 queues, equal share. That is to configure one single command. Now, along with the weight when you configure, when you mark and send through the same interface where fair queue is enabled, now it becomes a weighted fair queue. Same configuration, but the traffic is coming with markings. According to the marking, the weightage is going to be given. Now comes the important point. We give manual priority. See, in the previous case, it is dynamic bandwidth allocation. It is automatic classification. But not everyone will be happy with that automatic and dynamic. I want to say for Telnet and SSH. You see, even though they are TCP traffic, they are important than FTP. They are important than FTP. So I want to classify, and then I want to allocate per class some bandwidth. So this has got more control than weighted fair queue, because I am in control. I decide how much of bandwidth per classification. Telnet and SSH give 20% of the total bandwidth. Just an example. I have the control. Whereas in the weighted fair queue, you don't have the control. Dynamic. Right? For that, we need to write a class map. I think I showed you this thing in the class, but I'm going to show it again. I was just showing this class map and policy map to show you the weights. AF, EF, all the stuff. We need to write a class to match some traffic and then take action like marking and providing bandwidth, etc. So there is no strict priority. We only decide. All right. For example, as I said just now, for video, 30% of the bandwidth. Voice, audio, 30. Video, 20. Data, 50. This is just an example. So what we do for voice, we match with the EF, and we call that voice here. We say 30%. And for all the rest of the traffic, I have given 70%. This is not a complete example. Here, these two are not done in the example. Only the first one, 30% is done. For all other traffic, it goes via class default. The remaining bandwidth is given to other traffics. At last, you apply that on the interface. This is widely seen QoS. This QoS is widely seen in production. We match some protocols, and then we put some markings, and then we say how much percentage we want to give or how much bandwidth. You can say bandwidth in kilobits. You can also say in percentage. Now, this is also another one which is seen in production, but this is not going to come alone. It will come with CB WFQ. This and the next one will be combined and used in the production. See, some production don't use PQ, priority queuing. They use only class-based weighted fair queue, CB WFQ, which we just saw. But some production have got both PQ and class-based weighted fair queue. These two put together has got a different name called LLQ, which we are going to see next. For that only we are learning what is PQ. Priority queue is like this. In some countries, in Middle East, I've seen, there will be one road which no one can use except the king. And there will be one part of airport where no one will be able to access except that king and king related family members and security guards. How much ever the traffic may be in the common road, no one will be allowed to use that road which the king is using. Still there, such countries are there. I've seen in my little eyes. That is called priority queuing. That queue will be always there. Whether there is enough bandwidth for other traffic or not, this road will not be given to anyone. It is only reserved for the king. Likewise, you can create a queue and reserve a bandwidth which will never be given to anyone except for that traffic that which you created the queue. For example, if you say voice and video will use PQ and the bandwidth will be 50%, only for voice and video that 50% will be used. will never be shared with anyone, any other traffic. That is PQ. But that's very bad, no? When voice and video is not there, that bandwidth is not going to be given to anyone. So all the traffic that is using PQ will never be stopped for any reason. Any congestion happen, that will never disturb the members who uses this lane called PQ. Always sent first, you see, high queue away, always sent first. Now, only PQ is not good. So what they do is they mix. That's the problem, The problem is the starvation of bandwidth. You will not have enough bandwidth for others. So LLQ comes into picture. LLQ is nothing but the combination of these two which you learned now. PQ plus class-based weighted fair queue. PQ plus class-based weighted fair queue. We saw in class-based weighted fair queue, we create a lot of class maps and we provide different levels of prioritization for each class. Along with that, you put one queue, which is PQ. So these two concepts together is what called as low latency queuing. This is also seen in production. So in production, only two I have seen. One is LLQ, another one is only CBWFQ. These are the two things. For to do these two only, we have got this chapter called QoS. Class-based weighted fair queue. Most of the customers have got wherever QoS is deployed. And low latency queuing also seen in some customers. It's also in a big number. LLQ. I hope you understood now the types of queuings. And now what comes is only the practical part is left. So before we do practical, let us see one example here. Similar example is what I'm going to do in our next class. You see, this is an example for LLQ. For voice, you have a strict priority queue. And for other, like Vivo IP and video, you have class-based weighted fair queue. For voice, you provide EF. EF means expedite forwarding, high priority. And for video, you give some certain guarantee of bandwidth. Sorry. You provide some bandwidth. And let's see how to do it. See, first of all, you match all the EF traffic. EFs are nothing but what? Voice. So you create a policy map and you call that voice class that we just created. And we say priority. That's the keyword to create priority queuing, PQ. Priority percentage 20, which means 20% of bandwidth will be always waiting for voice. But when you say bandwidth percentage, it's not going to wait. If someone needs, when the traffic is not there for this queue, someone can use this queue, use the bandwidth. That is this. But this one is strict pipe, like a king's path. No one else can use. All right, that's the example. And now here is the quick comparison. We learned a fair queue. It is flow based. Just to summarize, there is no class based and there is no priority. There is no bandwidth guaranteed. It is dynamic. Starvation risk and all, you don't have anything to talk about it because you don't decide. It equally shares the bandwidth. But for voice and all, it is not good. Because for voice, you need special attention. Now, weighted fair queue, is also flow based, but the bandwidths are dynamically allocated according to the weightage, like EF, AF 11, AF 13, weightage. So compared to other one, this is okay. Class based weighted fair queue, it's not flow based, it is class based. It is class based. There is no priority queuing in it. We create queue and we give different bandwidth. If there is no traffic to use the queue, that bandwidth will not be blocked. It can be given to others. So no much starvation, but it is good. Now what about PQ? PQ is dangerous because it blocks. For that traffic, it is very good, but for other traffic, it is starvation risk. Again, it is class based and not bandwidth, it is priority queue. You saw the command also. LLQ is the excellent one. No starvation. We decide, that's why it is called a self. We decide how much bandwidth to give to which class of traffic. And we also have a priority queue and say, if these traffics comes, they go into the priority queue, which will never be stopped at any circumstances. And of course, we use class because PQ is nothing but, LLQ is nothing but PQ plus CBWFQ. Right. Any question on different types of queuing methods? We have learned 4 different types of queuing methods.